Hello friends and welcome to my channel. If you will watch this video, you will learn how to repair an auto amplifier like this. First of all, I have to tell you, any auto amplifier it's made like this. I took the case apart. The case it's a heatsink for these MOSFETs. And any auto amplifier it's made from three parts. Here it's first part. First part it's the power supply. It's a classical step-up converter, 12 volts input, and here plus minus 30 volts output. This second part, it's a power amplifier. As you can see, there are four power amplifier AB class. It's classical. And this third part, it's input preamplifier crossover part. This is filters, cutoff frequency, low, high, and any adjustment that we have here. Now let's talk about this power supply. This is the case of this power supply. It says 1100 watts MOSFET amplifier, but it's not this much, because here we have plus minus 30 volts, and this plus minus 30 volts can give us 60 real watts on 4 ohms on one output. And if we use bridge output, this can give us maximum 100 watts, 100 and something watts real RMS. Now I will tell you how I repair an amplifier like this. First of all, you need a power supply, 12 volts and current limiting. I start 13 volts and 1 amp current limiting. Because if something is broken, I want to see and not made it even worse. That was in the beginning. Now I will tell you how I repaired this amplifier, but in the beginning I thought it was a very simple job and I didn't film this from the beginning. After I start to repair, I noticed that was a very difficult job, and that's why now I made this video after I repaired this amplifier. Now let's start with the beginning. First time when I took this apart, I noticed these two MOSFETs were made pieces, and these two MOSFETs were good. And first of all, I replaced these two MOSFETs. Initially was IRFZ44, and I found only IRFZ48. And initially I replaced this 44 with 48, and this 44 I let the original one. And I believed that if I will replace these two MOSFETs, this amplifier will work good, but was not the case. So I replaced, after I replaced these two MOSFETs, I put on this power supply, and as I tell you, 12 volts 1 amp, and instead of 12 volts and 1 amp, the power supply gave me 6 volts and 1 amp, because something here was taking too much power, and that's why the voltage was limited to the current, the 1 amp. And after that, these two original 44 was very hot, and 48 that I replaced was not very hot. I put this oscilloscope on these MOSFETs, and apparently they were working good. They were not saturating, they was oscillating. I will give you a picture with this schematic of this power supply. After I noticed that it's not working, I replaced also these 44 MOSFETs with 48 MOSFETs like this, to be sure that this is perfectly balanced, because 48 is more powerful than 44. After I replaced also this 44 with 48, was not working. Symptoms was the same. On the power supply I had 6 volts and 1 amp, and this was very hot. And now I tell you what I did after that. There was two possibilities. Even this power supply is bad and this amplifier part is good, or this power supply is good and this part is bad, and this is taking too much current from secondary, and that's why it's taking too much current from primary on this SMPS transformer. And to verify, I broke this circuit. This is one half and this is other half. I broke two wires. This is plus minus 30 volts, and I took off this half. After I took off the power supply for this half, I noticed that also here it's a great power consumption, and I presume that problem is not here on this power amplifier part, and it's in this power supply part. After that, I put back this connection and I connected two halves, and I put this on external power supply. I took this 12 volts off and I put here on this capacitor. This is plus minus 30 volts. I put on this capacitor plus minus 20 volts, and I limited the current to 1 amp to see what's happened. And I noticed that even I have here plus minus 20 volts, the current was very small, 1 or 2 amps. And that means that this block is good. This part it's good. And this told me that the problem is here. It's for sure in this power supply part. And I checked every piece. These are rectifier diodes. I checked this and they are good. This was replaced. I checked every resistor and they were good. I checked every transistor here and they were all good. Here are some diodes, and I check also these diodes. They were all good. And the only part that can be broken remained this IC. It's classical 494 IC, power supply driver. And I replaced this IC. After I replaced this IC, this is the bad one. And these are the 44 MOSFETs that were good. These are the 44 MOSFETs that are not good. Now let's power this up and see what happens. So 30 volts and 1 amp limit. Now, as you can see, we have 30 volts input and only 0.5 amp power consumption. When this is not working, any of these MOSFETs doesn't have to be warm if this has not a problem. So this should be like when an amplifier is good. Now let's see the signal. Let's put on AC. And we have peak to peak 25 volts and 31 kilohertz frequency. This is one pair of MOSFETs, and other pair. As you can see, it's 180 degrees dephased. It's backwards. They are working one at a time, not in the same time. So now the voltage is good, frequency is good. Now let's measure the voltages. Input, we have 30 volts input of the power supply, and the output of power supply, it's minus 25 and plus 25 volts. Now let's talk about this second part. This second part, it's a classical AB class amplifier. It's 2 BJT transistor, final transistor, and these small transistors here. The most vulnerable part are to these power transistors. When you made a short circuit on the output, one of these can broke, or these power resistors. The rest of parts, in 90 cases, they are not broken. And this input part generally is not broken only if you put here too high voltage signal. Otherwise this cannot break. Now let's make some tests with small power to see if this is working. To test this amplifier, I will use this tester, was made by me. I hope that you have seen my video about this tester. If you don't and you want, you will find it in this playlist. So, from first part, this is the signal generator. I will take signal out with this cable, and this signal will be to the input of this amplifier. This speaker output is connected here to this speaker. Now let's connect an external speaker, and I will use this signal as a signal source. Now I've connected this signal source, and this is a speaker. Now let's power this up. Let's start this. Let's make sure that the volume is down. The gain is minimum, and the gain minimum. Now let's start this. You can see when the volume is up, the current consumption is increasing. Now we have filter full. This is not working. I have to clean this switch. Now on this low volume, these are the two These are the two power transistors that are working, but they are not warm at this low volume. But if I will make a test to the maximum power, I have to put this on the heatsink again. Now I have to clean all these switches because they are not working good, as you can hear. If you have questions, please put it in a comment. I hope that you like this video, and if you did, please like and subscribe. See you in my next video. Bye.